Severe storms. In this part of the notes, we are going to look at thunderstorms and tornadoes. So before we talk about our severe storms, let's first take a moment to review our high and low pressure systems. So I'm going to let you pause this video while as a class you try to review them. Try doing this without looking at your notes. It's more helpful if you quiz yourself to see what you can remember rather than just reading something off of a paper. So go ahead and pause the video. Okay, so for your high pressure systems, high pressure is going to have your good, clear weather. High pressure, so it's going to be fair and sunny. The reason it's fair and sunny is because there is sinking air. Remember, in order to get a cloud, you must have air that rises up and brings moisture higher up into the atmosphere where it can cool and condense to form a cloud. If you have sinking air, you cannot get a cloud. So that is why the weather characteristics are fair and sunny. Remember, high pressure is going to spin clockwise, and counterclockwise is going to be the low pressure systems. So let's go ahead and review low pressure. So with low pressure, you have rising air. So the air is going up. This is going to create a bunch of clouds, which is going to be able to give you that bad weather. Low pressure systems spin counterclockwise. As it's spinning counterclockwise, remember, if you have a low grade, it's a bad grade, and you got that because you were counterproductive. And I know I misspelled counter, but you were counterproductive, which will give you a bad grade, which is a low grade, and you need to bring that grade up. So that is how you can remember your low and high pressure systems. Let's keep on going now that we have that review. So a thunderstorm is simply a storm that generates thunder and lightning. Yes, you do need to write all of this down. So a storm that generates thunder and lightning, that is a pretty basic definition that you probably could have came up with even without seeing these notes. So we all know thunderstorms have thunder. That's in the name. And whenever you have thunder, you're going to have lightning somewhere, whether you see it or not. Thunderstorms often produce gusty winds. So all that means is strong winds. So you can have a very strong gust of wind just blow through, and then it can calm down, and then all of a sudden you can have another strong gust of wind. And these really strong winds, depending how strong the storm is, they can tear down trees, they can tear down power lines, and all sorts of stuff like that. Your thunderstorms are associated with your cumulonimbus clouds. Remember, cumulonimbus clouds are clouds that accumulate from a cumulus cloud. So you start out with a cumulus cloud, and as that cumulus cloud begins to build and build and build and get taller, higher up into the atmosphere, that is when it would become a cumulonimbus cloud. The higher up those clouds are, the bigger the tower, the more unstable they are. And we know that the earth likes to be balanced. So when you have a system that is very unbalanced or non-stable, that is when you're going to have some severe storms because the earth is trying very drastically to get back to a point of equilibrium or balance. So I'm going to move on. Remember to always summarize as you're writing. Don't write down word for word. Next, you have your 3 stages of a thunderstorm. You start out with your cumulus cloud. The cumulus cloud is, remember, the little fluffy cloud. Once the cumulus clouds or the storm becomes mature, that is when you're going to have the active time. So you've got a lot of rain, you've got a lot of lightning. That's a lightning strike. You've got thunder, all that stuff that's going on. You may even have some hail occurring depending on what the storm system is like. After you have the mature stage, it begins to dissipate, aka it begins to go away. So your storm starts as just a nice fluffy little cotton ball cloud. As it continues to grow up into a cumulonimbus cloud, the big giant one, that is when it turns into the mature stage, which gives you the rain and the lightning and the thunder. And then after all of that has kind of gone away, that's the dissipating stage where the storm is dying. One thing that can cause the storm to die is the lack of a warm updraft. If you remember that from our notes with fronts, remember all storms are fueled by a warm updraft, because that warm updraft is what continues to bring moisture up into the cloud, allowing the cloud to build and grow, and can cause that really large storm to occur. Okay, so those are your 3 stages: cumulus to mature to dissipating. I'm going to go ahead and clear the screen, and we shall move on. This is just a picture, so it shows the cumulus stage. Notice that you have that, and you don't need to write anything on here down, but notice you have that nice warm updraft that is building up that cloud. In the mature stage, you have the updraft, but you also have a cold draft going down, and the cold downdraft is what's giving you that rain. In the dissipating stage, notice there is no updraft. There's no updraft, no arrows over here. So that's why that storm is finally dying down. And so it's just going to continue to rain out some of that excess moisture it has. So within this mature stage, these clouds can be 50,000 feet in the air. That is extremely huge. So they can be 50,000 feet and just have absolutely giant storms. And I just think that's interesting, because we don't always realize just how large these clouds can actually be. So let's keep on going. This is a picture I actually took while driving down the road one day. So it was a pretty summer day, and you see a cloud like that off in the distance, and to us it just looks like a pretty cloud somewhere, but this actually is a very big storm. Anytime you have a cloud that large, that means there's some sort of storm going on, but it's just really far off in the distance, so you can't see the lightning and you can't hear the thunder. Or maybe it's not even lightning, maybe it's just a really, really heavy rainstorm. But with that much cloud right there, it is safe to assume there is a storm going on somewhere. But again, it's very far away from you, so that's why it just looks like a big fluffy cloud to us. You'll notice this a lot more in the summer when you have those pop-up thunderstorms. So within a thunderstorm, we always have lightning. Lightning is simply the buildup of static electricity. So if you put on socks and you have carpet and you kind of like scoot across the carpet floor, and then you go try to touch your brother or your sister and shock them, well, that's what's going on with lightning. When you have lightning, you have the atmosphere that's scooting across the ground, and it's building up that static electricity, just like if you were wearing fuzzy socks on the carpet. And with that static electricity build up, at some point you're going to have very different charges. You have the ground that will be positively charged, and you have the clouds that are negatively charged. And so in order to even out those charges, lightning goes from the cloud to the ground, and that will briefly just redistribute the charges, creating a balanced area again. A lot of people think of heat lightning. If you know Matt Engelbrett, he is the weather guy, the meteorologist from WITN. This is one of his biggest pet peeves. There is no such thing as heat lightning. If you have heat lightning is just lightning that's far enough away that you can't hear the thunder. All lightning is going to produce thunder. You just can't always hear it depending on how the sound waves are traveling. So sometimes you have lightning that's going from the cloud to the ground, and then other times you have lightning that is going from cloud to cloud, and then sometimes you have lightning that's going from the top of a cloud to the bottom of a cloud. And typically that's what we see when we think of heat lightning. It's lightning that's traveling between clouds, and we just simply don't hear thunder that's going on with it. So lightning can reach 4 miles out of the clouds. I'm about to show you a video about how lightning forms, and this is something he talks about, but the phrase out of the blue actually came because lightning can shoot out of the blue, which is why if they ever hear thunder, they're supposed to cancel a sporting event to make sure you don't get hit. So let's go ahead and look at 2 videos. One is a video of a tree getting hit by lightning, and the other is a video of how lightning actually forms. So I'll let you pause this video and switch over to those. So hopefully you enjoyed those videos. Thunder is simply the sound of rapidly expanding gases. So when you have a lightning bolt, the air is going to heat up very, very drastically to about 30,000 degrees, and then it's rapidly going to cool off. So think about, you have that lightning bolt that's extremely, extremely hot, and we know that hot air is going to expand because it doesn't want to be close together, so that hot air expands, and as soon as that lightning bolt leaves the air has drastically cooled, and so now the air is going to condense, and boom, you get thunder. So just like with the can that we looked at when we did heat transfer, you have that rapid expansion of the hot air that when it is drastically cooled off, it condenses, and it condenses very, very quickly. And that is when you get that clapping sound, which is thunder. And as you already heard, you can count off about how far away a storm is based on the time difference in lightning and thunder. Depends how big the storm is, because you might be hearing thunder from multiple sides of the storm, but that's always kind of a neat thing to try to do. So occurrence of thunderstorms. At any given time, there's about 2,000 thunderstorms going on in the earth. So thunderstorms are constantly occurring because they're constantly trying to balance out those difference of charges with the lightning and just trying to balance things out. Most thunderstorms occur in a warm, humid environment. So warm, humid, mainly that is like the tropics. So tropical regions are very, very warm, and they're also very, very humid. Your key word for this definition, and all of you need to make sure that you know this key word, or two keywords, is that thunderstorms occur in an unstable environment. An unstable environment. The more unstable the environment is, the more likely you're going to have a big storm. So unstable is what you need to think about when you think of thunderstorms. Thunderstorms occur in an unstable environment. Make sure you know that. Make sure you underline that. Make sure you star that. Just like with all keywords, they are important, and I wouldn't keep pointing out keywords if they weren't important. So make sure that you do know that. So we've got a lot of thunderstorms occurring on the earth. Most are in the tropics because they're warm and humid in an unstable environment. That is how you could have summarized this entire slide. So I will give y'all a second as you finish writing, and then we will move on to the next slide. Okay, if you did not finish writing the notes, that's fine because we have a brain break. So this is a very cool video, very fun one that students usually enjoy, but 5 facts of lightning for when you get struck by lightning. I don't know if any of you ever have known anyone who gets struck by lightning, but I had a friend and her dad got struck by lightning 3 different times. He really enjoyed watching storms outside, so he would just stand right outside their front porch. And you'd think after the first and definitely after the second time he got struck by lightning, maybe he would stop. But he didn't. He got struck by lightning 3 different times. It did not kill him, but I think it did mess some things up within him. But you will see some of the things from this video. So I'll let you go ahead and pause this video while you watch this fun one. Okay, I hope you enjoyed your lightning video. So now let's talk about tornadoes. So we know how big thunderstorms occur, but those large thunderstorms are what will turn into tornadoes. Now notice, tornadoes are a low pressure system. That should be obvious to you because we know all low pressure is associated with severe weather, and tornadoes definitely are severe weather. So tornadoes form when a cold, dry air mass collides with a warm, humid air mass. If I were you, I would definitely make sure that I did know this point, okay? And the key word there is collide. So I would put a star next to this in my notes. But tornadoes are low pressure, and they form when a cold, dry air mass collides with a warm, humid air mass. I always think about when you have a car collision. The bigger the collision, the bigger the mess, the bigger the wreck. So if you have a collision of air masses, this is something that's a lot more drastic, and that's what's causing this severe weather in terms of a tornado. And notice the cold, dry, and warm, humid, those are complete opposite air masses. And that is why when they meet together with such a collision, it can become a very violent storm. So the tornado extends down from a cumulonimbus cloud, and you typically have a lot of rain and hail with your tornadoes. So tornadoes typically form from a severe thunderstorm that also produce a lot of rain and hail and strong winds. And so tornadoes really aren't that well understood. It wasn't until very, very recently, like a couple years ago, that they got a decent understanding of what causes a tornado and what's happening within them. And yet we still can't predict them very well. They really can just say there might be a tornado, and then they can tell you, oh my gosh, there is a tornado, take cover. So we're still trying to gain a better understanding of tornadoes, and I'll tell you in the next couple slides of how they do form. But make sure you know this. And how do tornadoes move? Well, they are going to spin in a counterclockwise direction. And you already know that because you know that all low pressure systems spin in a counterclockwise direction. So on the sides, we have a cool picture. On the top one is just showing you a little tiny twister, and this other one is a much larger tornado. And this one would be scary because at night you wouldn't even be able to see that tornado. This photographer just got a very cool shot of it because there happened to be lightning that lit it up at that exact moment. But I'm going to go ahead and move on to the next slide. So if you do need to keep writing, you can take a second, but write very quickly so that we can keep on moving with our notes and finish this unit up. Okay, moving on. So here is an idea of how your tornadoes form. We have what we call wind shear. Wind shear is when you have this horizontal movement of air, and that basically causes the air to start to roll, as you see in this picture number 2. So with these severe thunderstorms, we have this strong wind shear that's just cutting through the wind and making it roll and roll and roll and roll. Well, we know that thunderstorms are going to have a strong warm updraft. So if you have this rolling air that's actually horizontal on the ground, this warm updraft will lift up that horizontal column of air or horizontal row of air and make it into a column within the cloud. And as that column of air in the cloud starts to spin faster and faster and faster, you then can get a funnel cloud that will go down to the ground. But the rotating air actually did not start in the cloud. It starts on the ground and is lifted by that warm updraft, and then can eventually come to the ground later. So again, that is a very new understanding of tornadoes that was very much more recent. So let's keep on going. Actually, I'm going to let you pause the video and switch to a tornado formation video so that you can see that. So again, pause the video and switch to the tornado one. This is just another picture showing you your tornado. I think it's very fascinating to see that this is what we see as a tornado, which seems very, very large. But look at everything that is powering that tornado within these giant clouds. So every time you see a tornado, whether it be, hopefully not in person, but a picture or a video, just know that tornado is actually much, much, much larger than what you see. And so you have that warm air that's going up, and you again have that cool downdraft, and you have heavy rain and hail. Typically, there is heavy rain and hail in front of the tornado, and that's why they say, like, if you're trying to be a storm chasers are actually very, very intelligent. For the most part, they are the actual storm chasers. They know a lot about meteorology. They dedicate their lives to studying storms. They don't just get in a truck and drive around like just a stupid person would. So one of the reasons why that is so dangerous to do is you typically have heavy rain that leads in front of the tornado, and this blocks the tornado from view. The other thing that tornadoes can do, and this isn't that understood why, but they can jump. So a tornado can, cause horrible devastation over here and then jump up and cause more horrible devastation there and nothing in the middle. I remember my mom's from Alabama, and there was this really bad tornado, and we went down to visit some family after the tornado had happened. And we were driving through the areas of the destruction, and one side of the road would be completely wiped out, nothing left but the plumbing of houses, and then the other houses wouldn't even have a shingle missing. Or you would have one house gone, the tornado jumped over the next house and hit the one on the other side. So you have two houses that are wiped out and the one in the middle completely fine. It's absolutely crazy how the behavior tornadoes have, and that's why they're so dangerous, is because they are not understood and they're so unpredictable. There's some very cool storm chaser shows on Netflix if you ever are interested in watching those. But you'll see a lot of their job is just waiting for storms that never actually happen. And then every once in a blue moon, they actually get a shot of a tornado. So they spend, hours and days just driving, and they'll just sit there and hope that storm will produce a tornado. But usually it's the storm on the other side of the country that did. So feel free to check that out. I do have some tornado video footage I'm going to show you. But I have a video of that that's kind of interesting. But before we get to that, I want to talk to you about the occurrence of tornadoes. So there's roughly about 770 tornadoes a year. So that's just on average. So we have a lot more thunderstorms than we do tornadoes. And the worst tornadoes that we are going to have in this area is not going to be in Greenville. I don't know what the worst tornado in Greenville ever was. I've never been here with a bad tornado. I don't know if I've ever been here with a tornado. Our worst tornadoes are going to be in Tornado Alley, and I have a picture of that on the next slide. But think about 2,000 thunderstorms versus only 770 tornadoes. Tornado season is April to June. It's associated with our severe thunderstorms, as we've already talked about. And the intensity is going to be based on, you can just write the F scale if you want instead, because that's the more well-known name. But it's based on the F scale. And we put everything on the scale based on the amount of damage that was caused. So just looking at the damage from a tornado is what shows us where on the scale we are going to put the tornado. So I'll give y'all a second to finish writing, and then we will continue on. So here is a map showing you where Tornado Alley is, in case you haven't ever seen it. But Tornado Alley is the central states right in the middle of the U.S., and it goes all the way down. Now, parts of like Alabama and whatnot are also kind of included in this band of area, but the yellow part is where you tend to have the worst tornadoes. A big reason that this location is so can have such bad storms is because it's getting warm, moist air from the Gulf. It's getting cold, dry air from Canada, which we looked at is the collision of those two is what can cause those monster storms, and that's exactly what you see going on here. You also have a warm air mass coming over here from California as well. So all of that together can literally create just the perfect storm. This is the F scale. Now, you don't need to write this down. I just wanted to give you an idea of it. So if it's a category 0, so it goes from 0 to 5, at the 0, it's less than 73 mile per hour winds, and the damage is just light. So remember, when we do our tornado scale, yes, there's a correlation to the wind speed, but we are really basing it off of the damage done in the area. So very, very light damage, maybe some branches down. F1, maybe there's some branches and some shingles. F2, considerable. You're talking about maybe some roofs blown off. F3, you've got houses destroyed. F4, you've just got, neighborhoods that are going to be destroyed. And F5, you have incredible and speechless damage. Now, to the point where damage has to be so bad, it's just speechless. You don't even have anything to say about it. That's got to be pretty bad. In the Tornado Alley area, you do see times where like an entire town will be obliterated and there will be nothing left. That would definitely be from an F5. And those winds are over 260 miles per hour. Another crazy thing about these storms is they can just happen in a second and be gone within a minute. So tornadoes can just jump down and then just leave within 5 minutes, and within that 5-minute time period, you can lose an entire town. So they can be very scary because of that, and there's very little warning. These are just some pictures of your tornadoes. You have down at the bottom at F5. That one obviously is huge. I can't remember exactly, but tornadoes can be miles and miles wide. I think the largest one was 10 miles wide, which is ridiculous. Then you have that cool picture again with the lightning. You've got a smaller twister, which would be more of an F1 or F0 up there. And then you have a funnel cloud that is coming down while another funnel cloud is also on the ground. So that would be terrifying if you lived in that area. But a cool shot for whoever got that picture. So a tornado watch and tornado warning. Yes, these are not bolded, but you do need to write them both down. Hopefully you're already familiar with these, but if you have a tornado watch, this is just a meteorologist saying conditions are possible to create a tornado. So we've probably got some severe thunderstorms going on. They know that there's the warm, humid air mass and the cold, dry one. And so they know that potentially there might be a tornado. So kind of watch out, keep an eye out, make sure things are good. Once you hit a warning, that means that the tornado has been seen by people. And so someone has called in and said, hey, I'm in Farmville and I see a funnel cloud. And then they would notify the surrounding area of that. Or they will see on the radar that there is some rotation going on. Remember, when we have our tornado forming, you have wind shear creating a horizontal row of air that's spinning. When the warm updraft picks it up and makes it a column, it creates spinning inside of the cloud. So if they see spinning inside of the cloud, they know that a funnel cloud may drop down from that. So anytime you've got that spinning or rotation in the radar, they're going to call a warning because they don't know if the funnel cloud has touched down or not, but they know there definitely may be one up in there. So that's why the warning comes out. So if you ever have a warning, make sure you take that seriously. Most of us don't have a basement because Greenville's too humid. But if you do have a warning, go in the bathtub. I remember one time Doug had just flown out to go to Michigan, and I was left home alone, and there was a tornado warning. And so I got the cat, and we both sat in the bathtub until that warning was passed, and I had my computer out with WITN going on, and but we were safe, and I don't think there ever actually was the tornado, but we were prepared. So always take those seriously. So that is all for the notes on tornadoes. I've got some destruction videos from security cameras and whatnot that have caught video, or what are they called? Tornadoes on video. So I'm going to let y'all pause or end this video actually and switch over to that one. Our next set of notes will be on hurricanes.